Okay, so yeah, the sine rule and cosine rule. What we use these for? Well, first of all, we've worked with triangles before in trigonometry, and we've also done Pythagoras, and you'll actually notice that this looks very similar to Pythagoras, doesn't it? Um, but the what we with Pythagoras and trigonometry and SOHCAHTOA, which is a just simple trigonometry, you can only do that with a right angle triangle. So what the sine rule and the cosine rule does is help us to work with triangles that are not right angles. You can still do them with right angles. There's just no need. If you know it's a right angle, then you just use simple SOHCAHTOA or Pythagoras. But let's look at, first of all, what all these A's, B's, and C's mean. We take any triangle and we label the sides A, B, and C, lowercase a, B, and C. The angles are always capital letters, and they are the A is opposite the A. So the angle A is opposite the side A, the angle B is opposite the side B, the angle C is opposite the side C. So we start off with the sine rule and with the cosine rule, and also there's another rule, there's another formula just helps you to calculate the area of a triangle, which is different to what you might already know, which use all the same terminology, all the same symbols. So it doesn't matter which side you label what, as long as you make sure that the C is opposite the C, the A is opposite the A, and the B is opposite the B. Other than that, it makes no difference at all. So what does the sine rule is the easiest one to remember, but it's a little bit harder to understand at first because we seem to have two equal signs here. So all it means is that this is equal to that, but it's also equal to that, and that's equal to that, and basically they're all equal to each other. So in other words, it's saying that if I take the length of one of the sides, so let's use a bit of highlighting so we can just make sense of all this a little bit more easily. So if I take this side here and divide it by the sine of the opposite angle, I will get the same answer of if when I do the same with another side, like B, and divide it by the sine of its opposite angle. So the length of that side divided by the sine of that angle will be equal to the length of this side divided by the sine of that angle. And it's also equal to the length of that side divided by the sine of that angle. Now, this rule is true if I flip it upside down. If you know a little bit about algebra and basically just how numbers work, this won't be too surprising. So, for example, if A over B is equal to, okay, I shouldn't be using A's and B's. I'm not talking about these particular A's and B's here. Let's say if X over Y is equal to W over Z, then if that's the case, so if that, then we can say that Y over X is equal to Z over W. So that's just explaining that bit there. Now, we're not going to talk about why this rule is even true. We're just going to use it. So as I say, this one's easy to remember because it's just that over sine that is equal to that over sine that and whatever else. The cosine rule is a bit harder to remember, but it's not that bad once you notice a pattern. So it's a shame that this is highlighted actually, because I'm going to write it out again. Let me just pause the video and I'll write it out again so I can highlight it with my colours. All right. So what have we got here? Well, we've got, if we take the length of any of the sides, it just so happens that this side, but I could have labelled this triangle differently. So if I square that side, it's going to be equal to the square of the other two sides minus the 2 times each side multiplied by each other, and then minus by the cos of the angle opposite this side here. So that's which letter. So the cos is the angle that's opposite that one there. And then that's really the only thing you need to remember, which angle is which, because after that we've got the B and the C, doesn't matter which way you add them, and the B and C doesn't matter which way you multiply them, right? Doesn't matter. And that's why it doesn't matter which way you label them, as long as the B is opposite the B, the A is opposite the A, and the C is opposite the C. So So if we look at the rest of it, we'll see it doesn't really matter. The only things that do matter are, well, things like you've got to remember to square these numbers. You've got to remember that's a minus symbol. And what else, really? I mean, as I say, this doesn't matter which way around the B and the C are, because, and that would make sense because you could label it the other way around. But just remember that's the angle of that one. Okay, so that's the rules. Now, how do I know which one to use? If we look at it carefully, in fact, let's get a couple of examples, and an example where we're going to use the sine rule, and an example where we're going to use the cosine rule, and we'll try to understand why we're going to use each one in each case. All right, so we've got some questions here. That's the front page, and that is the answers. So we've got all the different pages there, and we can click on this to open it up and look at the answers. Well, let's have a look at the questions for a little bit, and we'll just decide what rule do we think we need to use. Okay, so I will. So let's. I'm just want to pick one. Okay, this is the area of the triangle is going to be what the other formula which we've not looked at yet. The two questions I want us to think about are question 1 and question 4. So let's look at question 1. And if you're rewatching this video, you can always pause it at this point, and I just want you to think about not what if you could have a go actually answering the question if you're pausing it, but at the moment we're just interested in what are we going to use? Are we going to use the sine rule? Or are we going to use the cos rule? All right, is it the sine rule or the cos rule? That's question 1, and then question 4. Let's have a look. Is that the sine rule or the cos rule? So one of them's one of them's the other. I haven't been sneaky and made them both cosine rule or both sine rule. One of them is one and one's the other. Okay. So let me just pause the video and we'll have to think about it together. Okay, so you know already that because we got, like, if we look at question 1, then we've got so sine 33. We're trying to work out there. We're trying to work out BC there, yeah. So BC, which is this length here, that's opposite 33. So sine 33, and in fact, we could do BC over sine 33 would be equal to 15 centimeters over sine 112. Now, if they try and catch you out, and they might well do with another question. They might not give you that angle, it might give you this angle. But remember, all angles in a triangle add up to 180, so you'd be able to work out the third angle anyway. So I'm not going to bother doing that actually, but you can probably see that we're going to work that out and multiply it by sine 33. That'll give you what BC is. This one is the cosine rule. Let's see if I can remember it from the way I remind myself how it works. We want to try to find length BC again. So let's just label that as A, and it was that A squared, and as you can see, that's the angle that's opposite it, is going to be equal to B squared plus C squared. So we just add the other two sides, then we remember to minus, not plus, 2 times the both sides multiplied, and then we multiply that by the cos of the angle that's opposite that length, cos 55. Okay, so then we just sub in 23 squared, 20 squared minus 20 times 23 multiplied by cos 55. Okay, right, so that's the intro thing. So maybe we'll look at some more complicated questions then.